Welcome to the deep dive. Today, we are plunging into a world that sounds like pure science fiction, but is actually becoming engineering reality. Quantum computing. We hear the buzzwords superposition, entanglement, qubits, and, well, the research is moving incredibly fast. But the big question for you, our listener, is probably who's really building the commercial stuff now?
That's really the core mission for us today. We want to distill the current landscape. And based on, well, a lot of sources we reviewed, the timeline is still pretty long.
Long, okay.
Yeah, practical real-world use cases.
Oh.
They seem likely years away. And let's be clear, this means those pure-play quantum stocks, like D-Wave or IonQ, they remain largely speculative bets for now.
Got it. So if the pure quantum plays are speculative, where's sort of strategic opportunity right now?
Well, it seems to lie with the giants. We're focusing today on three huge players: Nvidia, Microsoft, and Alphabet.
Okay.
They're all playing this really smart dual-track strategy. They're making bank from the current massive AI boom.
Which is guaranteed money, basically.
Right. And they're using that cash and that infrastructure build-out to simultaneously shape the quantum future.
Okay, let's unpack that then. We need to look at the subtle differences in their strategies, right? Because they're not all doing the same thing, physically or software-wise.
Exactly.
Let's start with the one everyone knows from the AI revolution, Nvidia.
Right, Nvidia. Their foundation is obviously their GPUs. They're the powerhouse behind modern AI data centers. So their quantum strategy feels very pragmatic.
Pragmatic how?
Instead of going all in on some purely quantum machine decades down the line, they're embracing a hybrid model. They're blending classical computing power, which they dominate, with specialized quantum hardware.
A hybrid model feels like they're admitting quantum isn't quite ready on its own yet.
Strategically, yeah, I think that's fair.
Yeah.
It's a quickest route to getting something useful. They're really leveraging their existing strength. We see this specifically with their hardware collaboration. They're combining their top-end GPUs with quantum hardware from a startup called Quantum Machines. And that fusion creates the DGX Quantum. The goal isn't replacing classical computers. Not yet, anyway. It's about accelerating them.
Accelerating specific parts.
Exactly. Using the quantum bit for really tricky optimization or simulation problems, and then feeding those results straight back into the classical AI workflows. Think drug discovery, material science, speeding the whole process up.
And they're not just building the physical bit, right? They're building the software one, too.
What?
We need to talk about CUDA-Q.
Yes. CUDA-Q. That might actually be the most critical piece of their strategy right now.
Why is that?
Because they've designed this software platform to be, and this is their term, qubit modality agnostic.
Okay, qubit modality agnostic. Let's pause on that jargon. Why is being agnostic so important strategically at this stage?
Well, the big problem in quantum today is that different companies are backing different horses, physically speaking.
Yeah.
Superconducting qubits, trapped ion, photonics, they're all based on different physics.
And they don't talk to each other easily.
Yes. Not at all. An algorithm developed for, say, an IonQ trapped ion machine might need huge changes to run on an IBM superconducting one. It's like having totally incompatible operating systems.
Right, a mess.
Exactly. So NVIDIA's agnostic CUDA-Q platform aims to cut through that. It acts as a common layer. It means no matter which physical quantum hardware eventually wins out.
NVIDIA's software could still be the standard way to access it.
That's the plan. They become the essential translator, the middleware that makes it all work together, especially in those hybrid systems.
That is smart positioning, ensuring they profit from the infrastructure no matter what.
Absolutely. And you hear this from their CEO, Jensen Huang. He said, quantum computing is reaching an inflection point.
Yeah.
By controlling that key software layer and tying it to their dominant AI hardware, well, NVIDIA is set up perfectly to grab value from the earliest hybrid applications.
Okay, now this is where it gets maybe even more interesting. Moving from software integration to some really fundamental hardware innovation. Microsoft. Obviously a massive cloud company, but they've taken a very different, maybe much riskier path on the hardware itself. What's their unique breakthrough supposed to be?
Microsoft's big bet is on solving the core physics problem, stability. Or rather, instability.
Decoherence, right, the noise problem.
Exactly. Qubits are incredibly fragile. Noise just destroys the quantum state, kills the computation. Microsoft's answer, they claim, is their Majorana 1 processor. They call it a topoconductor.
A topological superconductor. Okay, more deep jargon. For the listener, what does topological actually mean here? Why is it supposed to be more stable?
Okay, think of it like this. Most qubits store information in a very delicate physical state, like the spin of an electron. A tiny vibration, a tiny temperature change can flip that state and corrupt the data. That's decoherence, easy to mess up.
Right.
A topological qubit, theoretically, stores information differently. Not in one tiny spot, but in the pattern of connections, the overall structure or topology of the material. It's like encoding information in a braid or a knot.
A braid.
Right.
Okay, I think I follow.
Yes. The information is stored non-locally, globally, across the structure. So small local disturbances, the thermal noise that kills normal qubits, can't easily unravel the whole pattern.
So it's inherently protected by its structure.
That's the theory. It
Right.
makes the qubit intrinsically more fault-tolerant, much more stable. That's the potential game changer with the Majorana processor.
And their ambition based on this is, frankly, staggering. They've talked about getting to 1 million qubits on a single chip. That's orders of magnitude beyond where anyone else is close to.
It is a huge claim. They believe this stability is the key to rapid scaling. And they say it could cut years off the timeline for truly useful quantum computers. But we have to inject some realism here.
Yeah.
The sources suggest that while the physics concept is sound, actually engineering these exotic topological materials reliably and at scale, that remains an immense challenge. It's definitely a high-risk, high-reward play.
So still very much in development, despite the big claims.
Very much so. But like Nvidia, they have that huge safety net.
Their cloud business.
Exactly. Microsoft Azure holds about 20% of the cloud market. And they're already offering quantum computing cloud services. They even partner with folks like IonQ and Rigetti to let researchers experiment today.
So they build the ecosystem and the customer base while they work on perfecting their own hardware.
Precisely. They create the channel to market, even if Majorana takes longer than hoped.
Okay, let's pivot to the third giant, Alphabet, or Google. They've also developed their own processor, but their focus seems less on exotic physics and more on, well, cleaning up the mess. The error problem.
Yeah, Alphabet has really zeroed in on fault tolerance, making quantum results reliable. They announced their proprietary processor, Willow, back in late 2024.
Willow, right.
And its main achievement was demonstrating a way to significantly cut down the errors you inevitably get in quantum calculations.
And the claim was pretty bold, right? They said they reduced errors exponentially. What does that actually mean in practice? Why is exponential reduction the benchmark?
It means you can actually start trusting the answers. See, quantum systems run on probabilities, and small errors can snowball really fast, making the final result meaningless.
Okay.
When Alphabet says exponentially, they mean that if you use more physical qubits together to create one stable logical qubit, the error rate doesn't just decrease a little bit, it plummets.
So like using 100 noisy physical qubits to make one good logical one.
Exactly. And maybe the error rate drops from, say, 1 in 100 operations down to 1 in 10,000 or 1 in a million. That huge drop, that geometric improvement, is what potentially takes quantum from a lab curiosity to something genuinely useful.
And crucially, they didn't just do this with the Willow hardware alone, they leveraged their biggest strength.
AI.
AI.
Precisely. It's a really neat synergy. Their top-tier research division, DeepMind, worked directly with Google's quantum AI team. They created a specialized machine learning system called AlphaQubit. Its whole job is to watch the quantum computation in real time and figure out how to correct the errors as they happen.
So it's AI acting as a super smart decoder.
Yeah, and apparently it outperforms traditional decoding methods because it learns the specific noise patterns of the hardware it's running on and adapts. It's AI fixing quantum's inherent flaws.
Which, again, really underscores that point about hybrid systems, doesn't it? It suggests quantum computing, at least for the near future, really needs cutting-edge classical AI alongside it to work properly.
That seems to be the critical takeaway, yes. AlphaQubit pretty much confirms that practical quantum is likely a hybrid game for the next decade or more. They're using their massive AI lead to clean up the quantum signal.
And of course, just like Microsoft, Alphabet is the #3 cloud player. Google Cloud.
Right, so they also have that massive built-in distribution channel to enterprises. They already offer quantum services through the cloud.
Positioning themselves to deliver these capabilities once the tech gets cheaper and more reliable.
Exactly. They've got the cloud platform, similar to Microsoft, but maybe their core strategic differentiator is using that world-class AI to tackle the immediate practical problem of making quantum results trustworthy.
Okay. So let's pull this together for the listener. We've got these three really distinct strategies emerging. Nvidia with its agnostic software play, Microsoft making a huge bet on fundamentally stable hardware, and Alphabet using its AI prowess to fix the error problem. But the really big story, maybe the most important takeaway for someone thinking about this space today, is the immediate win they are all benefiting from right now.
Absolutely. The immediate win is, without a doubt, the AI boom. Quantum might be the long-term hedge, the next frontier, but the current financial engine, that's AI.
Right.
The massive guaranteed investment flooding into AI infrastructure is basically funding all this quantum R&D. It's the safety net, but it's also the accelerator.
And the scale of that AI investment is just mind-boggling. We're talking trillions, right?
Trillions. We heard directly from Nvidia's CFO, the expectation is tech companies could invest up to $4 trillion just in the next 5 years building out AI data centers.
$4 trillion.
And Morgan Stanley put out a forecast suggesting AI cloud computing revenue alone could hit $2 trillion by 2030.
So $4 trillion is being spent right now laying down all this classical computing infrastructure. GPUs, yes, but also high-speed networking, power systems, cooling.
All the complex plumbing.
Exactly. All the stuff that quantum computers will eventually need to plug into.
That's a key point. This massive AI build-out is essentially pre-building a lot of the necessary surrounding infrastructure for quantum. It passively lowers the barrier to entry to integration cost when quantum tech gets more mature.
So owning these stocks now gives you exposure to both things.
That's the argument.
Yeah.
You get exposure to the dominant tech trend happening right now, this undeniable AI wave, and you also get a stake in the potentially transformative, strategically vital quantum future that they're uniquely positioned to shape. That dual exposure is what makes them, well, pretty unique strategic plays today.
That was quite the deep dive. Okay, quick summary. Nvidia is mastering the agnostic hybrid software with CUDA-Q, making themselves essential middleware. Microsoft's taking the high-risk, high-reward shot at stable hardware with the Majorana 1 processor, and Alphabet is leveraging its AI dominance via AlphaQubit to tackle the error problem on its Willow chip.
And maybe connecting this to the bigger picture, here's something for you, the listener, to think about. Given that we have to spend something like $4 trillion building out classical AI infrastructure first.
Right, before quantum really scales.
Exactly. And given that all three of these giants are focusing heavily on hybrid systems, error correction, agnostic software, it raises a question.
Okay.
Will the actual practical adoption of quantum computing end up being more dependent on the maturity and sophistication of those classical AI and hybrid systems around it, rather than just the raw power of the quantum chip itself?
Interesting. Like how ready the classical world is to use the quantum answer.
Precisely. What parts of the current AI build out the networks, the software frameworks, the cloud APIs will actually dictate how fast quantum can integrate and deliver real value in the real world? Something to chew on.
Definitely food for thought. Thank you for joining us on the deep dive. Keep asking questions, keep exploring. We'll talk to you next time.